So as you can see, I've got the Atari monitor once again on the bench. I have removed the switching voltage regulator, the one that is potentially suspect, and that little driver transistor. This guy right here, the C1008Y. I was able to get replacements on DigiKey for just a transistor. It's just a small NPN 60 volt, nothing special transistor, but even though it checked good, for 25 cents, I decided to go ahead and replace it. And then on eBay, I found replacements for the STR53041. I think these were 2 for $5, including shipping. So I thought, well, shoot, I'll give them a chance. I'm still looking for a schematic for the Samsung monitor. Absolutely no luck finding it. It continues to be kind of ridiculous that I cannot find a schematic for this monitor. I don't know what Samsung chassis this might be to find it in television service manual. The closest I found, and this is from a different SC1224 monitor, is this schematic, but the power supply is pretty similar. There's an STR47098 maybe that's a very similar device to what we've got on here. The schematic seems fairly similar. We've got the front end with the filtering. We come through a power switch. In this case, this is a double pole single throw, or on this it's a single pole single throw, but that's fine. Off to the degaussing coil, through a diode bridge, and back around to the main filter cap. I believe we measured 160 volts on the equivalent of this cap. So we know there was DC to this point. Hopefully I've got this in frame. DC to this point. Sorry, I probably got the lead in the way there. And then I just kind of came in and, when I saw various voltages poking around in here, but what I didn't see was any kind of oscillation back in here, and I would expect this to be oscillating and driving the primary side of this transformer here to produce the secondary voltages. In this case, it's producing the schematic 14 volts, 12 volts, and 100 and maybe 95, 175. It's kind of hard to read. And I expect this to be similar. There are 6 taps, and this is where this gets interesting to me. There are 6 leads on the output transformer here. These 6 up here, so the power supply section is down here, and I've got these 6 leads up here. However, when I look, only 3 of the pins are used, and that's this pin, and this pin. It's a single-sided load on the board, or a single-sided PCB. That pin's completely isolated. That pin's completely isolated. And as best as I can see, that pin's completely isolated, which immediately says that this power supply is much different from this one, in that this has got 3 secondary windings to produce 3 different voltages, and this seems to have a center tapped secondary winding, and that's based on putting the ohm meter on it. And we can go ahead and do that again. Let me get the test leads here. And ohms. And if I look at the leads on this guy that are actually hooked up, I find 0.052 ohms there, 0.28, and that's not, I got good contact here, and 0.38 ohms. So there's definitely something going on here on that side. These other pins are just completely isolated. 67 meg. And if I look at these other pins in a continuity kind of mode, there's just nothing there. So I find this kind of interesting, because we looked at this before on the primary side, there's one isolated pin, and the rest all seem to, are tied off to go someplace. Ultimately, this is creating isolation between the switcher and here, and I guess ultimately there is a center tapped, and I'd have to follow this out. I mean, we've looked at all these other diodes, I believe, on the board. That's kind of interesting there. We've looked at, that's that voltage regulator we swapped out right there, the 7812. So, obviously part of the power supply happens on this side of the board as well. But this part of the power supply isn't going to work unless this side works, unless this oscillates and drives this transformer. Down to, there's not much left here this could be. And looking at this, we've checked the diodes on the power supply side here, on the switching side. Gone through them several times. We'll probably dive into all the semiconductors over here and just take a squiz around and see if I've got a failed diode, etc. Still, I would expect this side of the supply to come up and at least oscillate. There is, over here, this T501, which is a transformer, obviously. It has got a primary here. It measures out at, about 1 ohm, and there's a secondary over here, which measures at about 0.28 ohms. So there is a secondary here, and this is directly headed off to the flyback into what looks to be a ground, and it is. So, I don't know if this is feedback from the flyback doing something here, or if it's actually driving one of the coils on the flyback. Again, not having the schematic for this and the theory of operation helps, or doesn't help. I just don't know. Anyhow, I'm going to go ahead and swap in the couple of devices I bought. Once I can find the bags, we need one of these little transistors, and I'm going to assume he's good. He should be. I mean, stranger things have happened. It would be just my luck to actually get a bad transistor here that I'm replacing a bad transistor with. Get his little leads through there. Flare him out a bit so he doesn't fall through. And we'll go ahead and solder him up. Hopefully I've got this in shot. Of course, the leads get trimmed. And onto this switching controller here. It's the same process I talked you through before, where I will get it fully mounted first, and I will solder it after to help reduce stresses. Same as we saw before. It's got this little mica washer. I've of course got heatsink compound all over myself here, as I always do. This stuff is just difficult to work with. I'll get a little bit on here. Doesn't need much. I've probably once again overdone it. get him kind of lined up there. And of course I'm getting big fingerprints of heatsink compound on everything, as I always do. I just find this stuff difficult to work with. This is new enough that it should be, it's a synthetic ester base. I know the really old stuff had, I don't remember, something nasty in it, something that was carcinogenic. So I've gone ahead and lined up the screw hole with the hole in the mica washer. Let me pull the screw out here and wipe a little bit of the residual heatsink compound off of it. We will get one of the two replacement devices. Try to do this on camera. I guess I could sit down and electrically compare this to the one I yanked out, but I'm not going to go that far with it. He gets a little bit here on his backside, smeared around a bit. Don't want too much. And of course now I've got compound on the bench. If you don't clean this stuff up, it just spreads everywhere. It's sticky. And I will sit him down in place. I probably should have checked the lead spacing first, and I didn't. Yeah, that lead's pretty bad. Of course, it's rather difficult to get those to all line up. They are in. I do believe all 5 are through, and they are. And the screw's engaged. And again, I'm going to screw this down before soldering the leads. I've said it several times in this video series, I know, to reduce mechanical stress. And you can see the heatsink compound kind of squishing out around. I always use too much. Got my 5 nice leads there poking through. Clean up very well. That wetted nice. Just did that. Just did that. Soldering is, of course, you know, a mix of getting good contact to the PCB and the device lead to get heat on both. I don't like the way that pulled away. Not having so much dwell time that you lift the copper off the board, you have enough dwell time that everything gets good solder flow. It's as much art, in my opinion, as it is science. Well, now the question becomes, do I dare power this back up without everything hooked up? And I really don't. I did that before and I wasn't sure the potential ramifications. What I do think I'm going to do, however, and I swear I've done this before, is walk through diode there just doesn't look good. Just kind of walk through one more time with the diode checker and check all the diodes, and come back and check all the transistors over on the driver's side of the board. So there's a little diode right here. That is open. No. There it is, 0.5 forward. I'm obviously looking back into a capacitor. I hate this because I'm about going to have to pull one lead out. Nice solid 0.5 forward. There's a capacitor behind him charging someplace. Giving all the components a good visual look here. I don't see any blown tantalums. So 0.45 forward. There's something behind that diode charging. This might be a little easier to do on the bottom of the board since it is silkscreen labeled. Got a diode right here, and that should be forward 0.5. About going to have to lift some of these out of circuit. For now, I will look for, obviously, shorted. Of course, got this big driver transistor back here on the high voltage. Oh, he is shorted. Base to emitter, dead short. Collector to base, normal 4. Now the question becomes, is that I'm seeing back through something else in the circuit, or is that really a failed driver transistor in the high voltage? The only one way to find out, and I'm going to remove him. Just get him isolated here. Probably should have done this right in the first place. Another mica washer. Oops. It has got a nut on the other side of it. Oh, good Lord, why would they do that? That is going to make putting that back together just a laugh a minute. Why that isn't threaded into the metal heatsink there is a complete mystery to me. It is, there, it's loose. Okay, that's just a piss poor design. See a washer. Q302. So let's see, we are No, he is shorted. Yep, this transistor is bad. So from base to collector, I have 0.5 volts forward. From base to emitter, I've got nearly a dead short. If I reverse the leads here and go base to collector, I've got an open. And if I go base to emitter, again, I basically got a dead short. So this is definitely a bad semiconductor here. It's a pity I didn't check that before. I got so focused on the power supply being the issue. I'm going to see if I can, that mica washer is going to peel. I'm just going to leave that mica washer on there. It wants to peel apart, and I will reuse it. But I can wipe off some of the really dead heatsink compound. Now the question is, do I have anything to replace this with? Yeah. It's a D1398. Don't know, based on that part number, what it is or isn't. You know, if the high voltage isn't running, and there is that feedback directly from the high voltage to this essentially transformer sitting here, it's T501, we looked at it before, that may be what's providing feedback to the power supply that closes the power good loop. Although who knows, anything's possible, but that might actually explain the core issue here. Who knows? So I'm going to have to dig and see if I have a suitable replacement. I've actually got a place to start here. I've got a lot of, almost all MOSFETs that have come out of switching power supplies, but that's just a set of diodes. So I may have to go cross-reference this. Luckily, the other DigiKey order that I put together today for a different project I haven't submitted yet, so I could order a replacement for that if I had to. You know, I hold on to stuff like this. They got good sill pads underneath them. The semiconductors can be reused quite often. I think these are from that Reclaim switching power supply I did. I'll have to look through a couple other boxes to see if there's actually something that says D1398 on it. But I'm going to flip the board back over, and I'm just going to continue to walk through with the diode checker to see what I see. 0.45 forward, open in reverse. Might be a... Oh, it's a ferrite bead. The symbol kind of threw me there for a minute. Again, looking back through a capacitor. 0.7 volts forward, 0.7 volts, and if I reverse here, so that transistor looks like it's probably okay. That's that voltage regulator. There is another power device here. 0.6 forward, 0.4 forward. Open. I think I'm maybe looking back through the circuit and seeing something else, although that doesn't look right to me. There's another one I think I need to remove from the board and test out a circuit, just because what I'm seeing doesn't seem right to me. Often the only way to get a good clean test of a device is out of circuit, so you're not looking back through, say, the rest of the system. He is not on a heat sink back here. C1507, I don't know offhand what that is. No, he looks completely normal now. Open and open. He looks absolutely fine, so we'll just put him right back into service. Afraid of that. Bend these leads over a tad bit just to help hold him in place. So he'll hang there. Well, sorry about the phone call there. I just spent a few minutes and dug through a lot of my reclaim stuff, seeing if I could find an equivalent transistor to that D1398, and I don't believe I have anything here that'll work. But before I actually go off and order it, I'm going to keep poking through the other semiconductors here, deeper into this supply, and see if anything else pops up that needs to be replaced. Before I actually place the order. I've got a lot of glare here. It's a connector. Capacitor, resistors, ferrite bead. Diode here I don't think I've looked at. He looks fine. That's a potentiometer. There's a Zener diode sitting here. It acts like a diode, so I'm going to assume it's good. There's another diode right here. Got a good forward voltage. Open the other direction, which is good. There's a diode here. 0.598 forward. Open reverse. I believe we looked at this guy already. Transistor. It looks completely normal. There's a diode sitting here. And he looks fine. There's another transistor sitting here. He is suspicious. That little guy right there. There's two of them here getting together, and that one is suspicious. It'll probably be fine out of circuit. .7. Yeah, this little guy right here is suspicious, and it looks like he has been potentially replaced once before. So let's go ahead and isolate him. Hopefully at least some of this is on camera. It's this little guy right here. the lead sufficiently isolated. Luckily the orientation is printed in the silkscreen. Makes it a little easier to make sure we get him back in correctly. He's an A708Y. Let's take a little peek at him. It's a good forward. It's a good forward. Good reverse. Good reverse. Just one more time. It's always a little fiddly to do. What? Now it looks funny. There it is. He looks absolutely fine, so let's get him back in. This might be a little bit tricky to do. It's pretty tight down in there. Flares leads a little bit, keep him from falling out. Double check the orientation, and it's correct. Now he ended up a little closer down to the PCB than he was originally, so I do need to trim these legs off, but of course that will make it harder if I have to pull him out and put him back in again. I don't like the looks of one of those solder joints. It's a little better. And we'll just kind of keep working our way through. We've looked at this guy. He seemed fine. There's a diode here that I think we've already looked at. There's a connector here with a big ugly, what the hell that is on there. There's a wire poking through is why that looks so ugly, and I saw the wire move. Okay, they didn't use a connector, they directly soldered the wire in there, which is fine. There's another transistor sitting here. Good forward, good forward. Open the way around. I'm looking back through the capacitor, it looks like. Another diode. There's capacitor charging is about 0.6 forward. An open reverse. I believe already looked at this guy. I think we yanked him out of circuit. The solder looks fresh, so I'm pretty sure we yanked him out and tested him. And I should get 4.6. There's obviously an inductor of some kind here, a little transformer. Inductor, we've looked at him. I think this is the guy that I pulled the one leg up out of some other time. Charging back to something. He's got 0.4 volt forward. And the voltage just sits and climbs in reverse, which says to me we're looking back at a capacitor or something. It's most likely fine. Ductor, that's the guy we yanked out. Keep walking around just to see if I've missed anything. We've got this little switch over here that I don't know what it does. Another trim pot. An open. There it is in 0.7 forward. This is where good sharp probe tips come in handy, and these aren't the sharpest, so you can get through the oxide on the surface of the solder joint. There's where the heater gets hooked up. I think we looked at this guy already, but he looks fine. That's the voltage regulator that we replaced earlier. I thought maybe I had a solder bridge there, but I don't. I know we've already looked at this one. Did we pull that diode out of there? 'Cause that doesn't seem right. That's forward biased. This should be reverse biased. That diode's suspect. In this case, we're going to have to isolate it. I'm isolating him by bending up one, or releasing one pin. Hopefully, get that one pin to fold up. If I get real lucky, I can just float the pin there in the hole and not necessarily make contact, although I don't think I'm going to get that lucky. These aren't plated through holes. So he is open in that direction, and that's correct. So I was able to get the pin isolated from the solder, I think. That is forward bias 0.58 forward, and open reverse, he's fine. Go ahead and kind of bend the pin back over the way it was. Yeah, with a plated through hole, you of course couldn't do that. It'd be impossible to fully isolate that pin, but with this just being a single-sided non-plated through board, just getting the pin up through the hole kind of centered so it's not touching anything was enough to isolate it. Sync. It's a jumper. That's a diode I don't remember looking at, though I probably did. It's another Zener based on the symbol. It should be 4 to 0.5, and then there's something charging behind it. But that looks good to me. There's an IC here that, if it's shot, who knows? Is that a connector or an IC? That's actually another IC. If either one of those is dead, we're pretty much out of business. Well, I'm encouraged in that this transistor, which came from back up here, There's the base over here to this side. And I see a normal diode forward. I see a short. I see a nice open from base to collector, and I see a short again. This guy's definitely dead, so I will see if I can cross-reference this and order one of these as well. We've got some capacitors to order, and we'll come back to this once I get the parts in. So, we're moving ahead. So I went downstairs to order a replacement for that dead transistor, and I thought, what the heck, I'll give Vetco a call. Vetco's here in the greater Seattle area. They have a really good stock of NTE cross transistors and components and just every tons of good stuff in there. And they had the cross-referenced part for it in stock. So I made a drive out there and picked it up. If you're not familiar with Vetco in the local area, it's one word, VETCO. I think it's .org, but it might be .com. Anyhow, there's a shameless plug for them. Let me open this bag up, and we will look at transplanting this device. Into the board here, I have some hope that this is finally going to fix it. The device did come with a replacement mica washer, which I'll go ahead and use. It's well insulated, so I can just use the bolt straight through. So I'm going to go ahead and clean off that old mica washer as well here, just to get it out of there. The heatsink compound behind it is very old and very dry. I know that's not all of the washer. The mic is peeling apart. There we go. It's just a very old, very brittle, very dead mica washer. Let me set this out of the way so I don't lose it. We'll see if we can scrape some of this out of here. It's pretty gummy. Might have to use a little bit of solvent on it. And looking at this device, it may have been replaced once before. It's hard to say, just based on the smear I see here. There's a good start. Let's see what we've got. We want that surface clean as best we can because we want it flat. I'll hit it with a bit of solvent here and see if I can knock some of that off of there. That did a pretty good job of wiping that out of there. Of course, now I need to find the backing screw for it. What I do with a little bin of screws and nuts and... Well, that's entertaining. It's completely vanished off the bench here. That's quite interesting. It was just sitting right here earlier. I obviously picked it up and placed it elsewhere. Where that elsewhere is anybody's guess. It's right here. And I should have that screw right there. And same procedure for this. We'll little heatsink compound, get the washer in place, a little bit more on the device, get it in place, get it screwed down tight, and then we'll solder it after it's in place. I'm going to actually just take a paper towel here and turn the screw a bit in it to clean some of the dead heatsink compound off of the screw. I'm obviously not going to get it all off, but we can get some of it off of there. That's a little better. So we've got the device, we've got the washer, which is actually still in its little bag. That mica washer's been around for a while. The date code on this, assuming that's a date code, is probably, well, that's not a date code. Hard to say. Anyhow, we will apply a bit of heatsink compound. Yep. I always get too much. It's just reality. Get him in place and square. Get him centered over the hole without hopefully pulling it back off. A little bit on the back side. I'm sure the leads are going to be long enough to stick out the bottom of the board. Oh, heatsink compound gets everywhere. It's just nasty, nasty stuff. Actually have some hope this is going to be the last issue and this will come up and actually operate. We know we had one bad electrolytic cap, and we had several others that were highly suspect, including a second one that I'm pretty sure was failed. If I can get that to line up. There it is. Oh, that's right, it had a nut on the back of it. Oh, this is going to be ugly. This is going to be ugly. I had forgotten just how rotten a position to work in that is. Let's get the high voltage lead out of the way if it'll stay out of the way. See if I can get lucky and get that to start. I'm going to need a better pair of glasses, and I don't know where they are at the moment. Hopefully this is still in frame. I'm afraid my really good pair are I'll be downstairs. This is going to be tricky. Reach in there with him. Not have a little bolt or the little nut rotate. And get good alignment there. It caught. Okay. Well, a little easier than I thought it was going to be, because I got lucky and the threads actually captured. And he's starting to pull up tight. That's good. Let me fire up soldering pencil. We've got 3 very long leads poking through there. I'd be very happy if that fixed it. I'd like to play with my ST again. Did a couple of mods in it. It's got a board that allows it to run later versions of TOS. And I probably should have shot videos on those way back when I did the mods, but I really wasn't doing the video blogging thing at that time. Those seem to flow well. Well, at this point, we've replaced all of the large electrolytic caps. We know we had one that was bad. We had one highly suspect. That's that lead. I don't like how much it's poking through there. I want to This is where I thought there was a bad solder joint to a connector earlier. And it was actually a wire soldered directly to the board. And the wire started to fall out when I heated it earlier. That's a lot better. I don't have a quarter inch of exposed wire there. Get these power resistors back up off the board so they can actually dissipate some heat. Leads on this one have got pretty deformed. That's okay. Just get him out there where he's got some circulation. He's okay, he's okay. That one's mounted really odd, but okay. At this point, we replaced all of these larger electrolytic caps. Like I said, we had a definitely bad one, and at least one of it was suspect, and a few was We've replaced the switching regulator device here. We've replaced a little transistor here that I think sets up the switching frequency for it. We had a bad transistor over here that is part of the drive for the flyback transformer. It had a short from base to, I believe, emitter, which would be a good reason for nothing to work. We've gone through all the semiconductors here and seen that they all seem okay. All the others, I'm just doing one more final kind of look over. There is sub-brightness adjust pot down in there. All the tantalum caps are intact. I think we're good to put this guy back in the chassis and see what we get. Chassis, I don't know, you hear me vacillate back and forth between the two names. Let's see, what orientation did this go in? It goes in this way. I've once again wire tied that board that goes to the neck of the CRT up out of the way. Just great strain relief for all the wires. These wires are loose. Start to put the screws back in. I know that these two corner screws here go to a grounding loop around the neck of the face of the CRT, so I don't want to put screws in those yet. Get a couple of screws started here. These were longer ones over here. It's that one. I believe it's these two. Well, that does seem excessively long. That makes me wonder if it was... There's two slightly shorter ones here, and now I honestly don't remember. We'll go with these longer ones. I've got enough screws in now that we know the alignments. Everything is okay. So we can go ahead and tighten them up. before I put this side card or sideboard card on, I've got to get the interface cable to the computer back in. It won't fit in with that little board in place, but this guy ran off to here. There was a little 2-pin that came to the most forward connector here. That much I do remember. These come around to that sidecar. Again, I will check this against the high-res photos once I get everything back in and plugged together. So let me move this aside. Bring back the most fragile part here, which is the CRT, which will not sit on its own. If I let go of it, it will rotate away, which is not good. As much of these cables out of the way as I can. This is a bit of a challenge. It's actually got a couple of oh, it slid right in that time. There's a couple of plastic kind of moldings that it moves up into, and it is these 2 screws. Started. This guy here. I can get him to sit in there long enough to get the screwdriver into him, which I can't. I don't want to lose control of this and have it fall over. And I dropped the screw on the floor. And of course, as everything works in here, the minute it hits the floor, it completely vanishes. I'm gonna have to look around on the floor here. It's amazing how far something can travel when you drop it. It's always amazing to me. I see it fall, and the second it hits the ground, it jumps off. There it is. Always jumps off in some random weird direction. Line up a little better. I have no idea how many times you've seen me put this back together. I think this is the 4th time. So, it's definitely progress. I know that this little guy goes here, a little piece of coax. This guy, I do believe, runs into a pretty difficult spot to get down into there. No, that doesn't seem to go there. Where's the... That's based on the way... comes out the sidecar. As does this. Why am I missing? There's the one I'm missing. Okay. Got two of these that are ground. This one's longer. It comes out to the board on the neck of the CRT. And this one goes right here. Got this little guy. Which goes down in here. How much of this is actually on camera? A fair amount of it. I can slide this over a bit. I will route all of these under. That is the degaussing coil. This is the power switch. And the rest of these, except for the speaker connector. Excuse me. Oh, excuse me. Loop around onto this little daughter board over here. That cable brings the video signal in from the computer. I know what those are. Why do I seem to have a number of extra screws here? That's actually kind of odd. Oh, I know. Okay, there's two shorter ones here. We'll get those in next. It'll be easier with this out of the way. As you can probably tell looking into here, cable management was an afterthought. Let's see if we can get him in about the right position. Get that screw in, which is here. If I can get the we've got an equivalent to that on the other side. And I'll come back around to that one. That would be that screw and these two. Okay, I know where all these screws go. So one of these goes through the grounding strap here and through right there. And ends up in that hole right there. The other one does the same thing over here. Make sure I'm not crimping any wires in there when I'm not. Two of these with lock washers. There's one of them and there's one on him. Go ahead and release this guy now. Get him back onto the CRT. Comes back here for a ground. This one and this washer. This is where it picks up the actual earth ground and the power cord. These are kind of important connections. There's a floating ground lead right here that comes up to the... It's just going to be easier to pop this board back off. Although I hate stressing and re-stressing. This ground captures right here. Pull a few tools out of the way because I need to rotate this. Get into this corner here. Okay, be stubborn. And that's the wrong screwdriver. Where did I set the Phillips at? Oh, it's always impressive when tools vanish. Always impressive. Wow, it's really gone. There it is. I'll try it this way. And I have got an extra screw that I do not know where it goes. I've got the 3 along the front there. I've got the 2 here. It's right down in there. I think it's the same one I missed last time around. Let's see if I can work the screwdriver down in there. Oh, so close. Afraid I'm touching the convergence thingamabobs there. Let's make a little more room. And coming at it from this side. There we go. So that's the last remaining screw. This guy wraps up around to here. This little guy right to here. There's only one place this guy can go. And as I did last time, unclear whether these are this way or the other way. Now I am going to stop recording, take a look at the photos, compare them to what we have here, and we'll see what we've got. Well, at this point I've compared all of the connectors, everything seems to be hooked up. The colors match the photos, which is a good sign. Again, I don't know which ohms here, and we'll take a peek and make sure the power switch is off while I power this up. So that is on. That is off. Just prefer to have the power off. We'll swing him around. I'm sure this is a pretty close-up view here. Key indicator to me will be the power LED down here. The isolation transformer is plugged in. What I'd love to have is that LED come on, and here's some high voltage crackle. And still nothing. Absolutely dead. God, that's disappointing. Volume, brightness. Absolutely nothing. I'm assuming this doesn't need video signal in to actually come up, though I don't know that. I was actually feeling really good about this time. But just no luck. Yeah, the isolation transformer's warm, so I know it's plugged in. Ooh, I've got a crimped cable back there. Hopefully I didn't damage. How did I manage that? I even checked this for clearance. That's something that's just plain not even hooked up. Wow. Even after, and I see where it goes. I just missed it. Even after checking the photos. See if I can get it to pull up through there. Not that I expect that to be a fix, but that's really a shame I managed to miss that. Funny that that unpopulated connector didn't jump out at me. Not expect that to make any difference. No heater on the CRT, no high voltage. Maybe we could be coming around to a dead flyback here. The fact that I don't even get any gross voltages. Well, I do that up that filter cap. Fuse is still intact. Well, I put a lot of time and a fair amount of money into this. Not sure what this little switch here is. Well, without a service manual, there's not much further I'm going to go with this. If I can't get in there and look at waveforms and get an idea of where this has failed, it's just hard to keep making guesses like this. Really hard to keep making guesses like this. Get on DC volts up here. And I should see 60 volts there based on 88 volts. So I know there's power getting in. It's just not a happy camper. Should not be using an uninsulated screwdriver in here. Absolutely nothing. The switching supply just isn't coming up. I'm assuming if the plus 12 volts was working, the power LED would light. I'm not going to have that much luck. Just not going to have that much luck. Yeah, there's nothing jumping out. Oh, that's a shame. At this point, I think I'm done with it. I've invested a huge amount of time. So I'll keep looking for a service manual, and if I don't find one, sure what I'll do. So anyhow, sorry to disappoint. Wish I had better news. We'll talk soon. Bye.